Welcome to Chapter 21, Capillary Exchange. If you have your outline, we are looking at page 3, close to the bottom, letter D. It starts with capillary exchange. There's also an illustration in your outline that we're going to be working with as well. I'm going to draw kind of a crude sketch of it, but we'll be able to use it. So when we're looking at capillary exchange, this is looking at the idea of how does the capillary do the job that it's supposed to do. As we said before, the whole purpose of the cardiovascular system is to be able to get blood to the capillary bed so that it can do exchanges of materials. And so now we want to talk about how it goes about doing that. So when we start thinking about this capillary exchange, we end up considering that we have a way of getting materials to the capillary, and we have a way of getting materials out of the capillary. So we're going to look at these structures. Okay. So instead of drawing a whole capillary bed like you would expect to see, because I want to label a bunch of things on here, I simply am going to draw a single capillary here, and the material is going to move this way. So at this end we have, oops, my A doesn't want to work so good there. We have an arterial, which would be bringing blood into the capillary, and over at this end we would have the venule, which would be taking blood back to the heart. Okay. And we have this exchange that's occurring here. So this region between the arterial and the venule is where we're going to see this exchange take place. Now, there are a couple different ways that exchanges can take place. The first one we can look at, and if you look at letter A, underneath this, the first mechanism is a mechanism called diffusion. And diffusion, if you remember from back in chapter 3, is movement of materials from high to low concentrations. The two big ones that we'll talk about are respiratory gases. And the respiratory gases that are able to move from high to low would be O2 and CO2, oxygen and carbon dioxide. This doesn't require any kind of energy, it doesn't require any kind of effort, but actually enables them to move across these walls without any problem. The second method that we use to get things across is filtration. And in filtration, these are when things are being pushed through the membrane, anything that's been dissolved into the liquid part of the blood into the plasma. So things like glucose and amino acids, hormones, those types of things will actually go through the holes in the endothelium and be pushed out by the hydrostatic pressure, the beat of the heart. And so that's going to move, we're going to make this purple, that's going to move this fluid out of the capillary bed and into the space outside of the cardiovascular system. This space out here is called the can't spell today. Let's try that again. That dot doesn't want to go away. Here we go. This is the interstitial space. And this space is outside of the cardiovascular system around all of the body cells. And so we have a lot of exchanges that are happening here. So this hydrostatic pressure allows for fluid with the things that are dissolved in it to move out of the capillary bed and into this interstitial space. This interstitial space is called the capillary hydrostatic pressure, and we shorten that down to be the CHP. So this is a hydrostatic pressure that you would find in your capillary beds. At the arterial end, this capillary hydrostatic pressure is at about 25 millimeters of mercury. As it goes across this capillary bed, the CHP actually drops, and I need to make a correction. It starts actually out, rather I said 25, but I'm going to actually fix that and say that it starts at 35. Let's see if I can get that 3 to work. 35 here. That doesn't look so great, but that's supposed to be a 35. And then about halfway across, we are at 25 millimeters of mercury. And then when we get towards that venule end, we're at about 18 millimeters of mercury. And this is a CHP as well. This is the pushing out pressure, right? So this is pushing fluid out of the, let's see if I can fix that 35, out of the capillary bed and into that interstitial space. So that's better. That's what's getting rid of the materials, taking things to the cells, so glucose and the hormones and all of those types of things. However, if you notice, right now I'm pushing everything out, and if I did that, I would constantly be losing my body fluid, and I need to, at some point, I need to be able to bring that fluid back in again. In order to bring materials back into my capillary bed, I rely on osmotic pressure. If you remember, osmotic pressure is kind of this pulling pressure, so it ends up pulling fluid back in. This is called the blood colloidal osmotic pressure, which we abbreviate down to the BCOP, and it has a pressure of about 25 millimeters of mercury, and it stays the same. This BCOP stays the same all the way across. So this is BCOP here, and this is the BCOP here as well at 25. So all the way across it stays at this 25 millimeters of mercury. And let's make sure, let's review this. So this CHP pushes fluid out of the capillary bed, and the BCOP pulls fluid back in to the capillary bed. Okay, so why do we want this? Because we're exchanging things. So fluid goes out, has things, again, I'm using glucose a lot, but that's one of the big ones, has things like glucose, has some of the hormones, like insulin, pushes those out. The body cells can use that. When the fluid gets pulled back in, it gets pulled in because there isn't, it gets pulled in with waste products in it, so urea and creatinine and those types of things. If you flip on your outline to the next page, the next part of that is looking at net filtration pressure. And net filtration pressure is your NFP. And net filtration pressure is the difference between the CHP and the BCOP. So it is the CHP minus the BCOP. And what this will do is this will tell you if materials are moving into or out of the capillary at any particular spot along the capillary. So if we start at the first one, right at where the arterial is bringing blood in, we know that the CHP is 35 and the BCOP is 25, which means that the NFP, the net filtration pressure, is plus 10. If it is positive, that means fluid is moving out. At the middle spot, we have, so this is the first one. At the second one, we have a CHP of 25, and we have a BCOP of 25, which means my net filtration pressure is 0. This is referred to as the transition point, because this is where I'm transitioning from pushing fluid out to pulling fluid back in again. So a lot of times on your illustrations, this transition point is marked with a dotted line, so we know that this is where we're moving. So from the arterial side to the dotted line, fluid is being pushed out, and from the dotted line to the venual side, fluid is being pulled back in again. We'll look at that because if we take a look at the next mark that we have here, towards the venual end, we see that the CHP is 18 and the BCOP is still 25 millimeters of mercury, which means that the net filtration pressure here is -7 millimeters of mercury. We have a negative number, and when I have a negative number, that means more fluid is being pulled in than it's being pushed out. So I push fluid out till I get to that transition point, and then I pull fluids back in again. That helps me to maintain my blood volume. If everything would be pushed out and never pulled back in again, that would be a problem. So that lets us take a look at a couple of unique things that can happen in your body. One of those is if you are hemorrhaging. So if you look at the homeostatic imbalances, you'll notice that you can recall fluids by a hemorrhage. And if we have a hemorrhage, what we're going to see happening is these numbers are going to change. So rather than a BCOP of 35, rather than a CHP of 35, we're going to have a CHP that's going to be less than that, maybe something around 30. Okay, that means that as the fluid runs from the arterial side to the venual side, it's going to reach that transition point sooner rather than later. And if that's the case, that's going to allow for us to recall fluids and actually pull those fluids in more easily. I'm not going to worry about the other homeostatic imbalances that are listed on your outline. The rest of the notes that you need to know for Chapter 21 are going to come from the interactive physiology activities that you're supposed to do. Those assignments are on Blackboard, so make sure you take a look at those. I will modify the exam slightly to reflect the materials that I've given you here. Please feel free to ask me any questions if you're not understanding what's going on with this capillary exchange and the CHPs and the BCOPs and those things. Alright, I hope you enjoyed the video. I hope you're having a great day. I'll talk to you later. Bye.